rotate it this way. So now we're going to talk about rotating around the y-axis. We're going to draw our picture again. Again, I have the curve 2x. This is a y equals 2x graph. And I have y equals x squared. Now, what I told you when we were doing u sub is if you change your d into a du, everything in the equation of your integral also needs to be with respect to u, including your bounds and your equation, okay? So it's not going to make sense. This time I'm going to have a volume equals, that's still my bones of the equation, pi integral something squared minus something squared. However, since I'm rotating this one about the y-axis, this is going to be a what? dy. This is going to be a dy, which means my bounds have to be in terms of y and my equations have to be in terms of y. Meaning my equation is not actually going to be 2x and x squared anymore. Instead of isolating the y to get something in terms of x, we're going to have to do what? Isolate the x to get something in terms of y. So you can do that off to the side. If you have y equals 2x and you isolate the x instead in that equation, the equation becomes x equals what?
Y over 2.
Y over 2. I'm going to relabel this as y over 2. What did I do before green? So this equation is now x equals y over 2. You really just need to call it y over 2 because we're going to be doing everything in terms of y. Okay? We also need to figure out the other equation. So this was y equals x squared. So y equals x squared, if we write that in terms of x, would be x equals what? Square root of y. Now technically when you take a square root, you get a plus or a minus, right? But we are only including the plus because we're only in a place where x is positive for our specific region bounded. If we had it over here, it would be negative. It would be negative the square root. But our x is positive over here, so that's why we just get x equals the positive square root of y. Okay? Does that make sense so far? I would not keep these labeled as x squared or 2x. I would call it square root of y and y over 2. Okay? For the three of these, we're going to be using those two equations because we're revolving it this way. Does that make sense to everybody? Okay? So, one final thing we need to do. We knew that this was x equals 0 and x equals 2. Those were x bounds. Now I need to know the y bounds. How do I find those y bounds? Yes?
Plug in your x bounds into the y equals x squared.
Yep, and you can plug it into either equation, right? Because they're the same, they're intersecting at those same places. So I can plug, okay, well if x equals 0 and I plug it into y over 2, right? If x equals 0, or I plug it into here, y equals 2x, you get 2 times 0, which is still 0. So my y bound is still a 0 on the bottom. But on the top, my y bound is no longer 2, right? Because if I plug x equals 2 into either of those equations, I would get what y value?
4.
You get a 4, okay? So now we're not going from x equals 0 to x equals 2. We're going from a y equals 0 to a y equals 4. You don't have to label this as y. I'm just doing this for you guys to clarify. Maybe in your notes on this first one, you put a y equals 0 and a y equals 4. Okay? Now everything else is the same. I put my marker on the thing I'm rotating it about. In this case, it's the y-axis. I'm going to draw it to the furthest away function. The furthest away function is the blue one. Now, the distance from the y-axis to that function is this equation. Okay, that is the distance from the y-axis to this function, just like it was the distance from the x-axis to that function. Does that make sense to everybody? Okay, so my r out in this case is the square root of y. That's my farthest away function. My r in, I'm going to draw it to the green. So my r in is the closer function. The distance from the y-axis to that green is y over 2. You want to make the last thing you're doing your r out and your r in. You want to make sure the whole setup is right. You have the word volume, you have pi, you have your bounds, you have your squares and your minus, and your d whatever. Last thing you should be doing is figuring out your r out and r in. Does that make sense to everybody? Okay, let's do 2 more. X equals -4. These are the 6 different situations. There are not any other situations you can encounter besides these 6. This is only how it will work. They'll either be on the x-axis, below or above, on the y-axis, to the left or the right. That's it. Those are the only options we're gonna encounter. Okay, so again, we're gonna draw my functions here and here. Make sure you label them. We're gonna label them in terms of y, like we just did on the last one. Okay, so the green one is y over 2. The blue one is the square root of y. This time we're rotating it about x equals -4. So x equals -4 is somewhere over here. You want to draw that line. Then you want to write the bones of your equation. Volume equals pi integral something squared minus something squared dy, since I'm rotating it like this. We're getting a dy. Okay? What goes on my bounds here? 0 and 4. With your partner, I'd like you just to spend a moment and see if you can figure out what the R out is and what the R in is. With your partner, I'm only going to give you about 30 seconds. Go. Okay, that was about 30 seconds, I think. Okay, we're putting our marker, pen, pencil, whatever, on the thing I'm rotating it about. That's always where you start. You always start by putting it on the thing you're rotating it about. Then, for R out, which is always the one you're finding first, you're drawing it to the farthest away function. The farthest away function is that blue function, which is square root of y. The distance from the y-axis to the blue function is square root of y. I'm making that radius longer. Does that make sense? It is adding another what? 4. So what is my R out? Square root of y plus 4 or 4 plus the square root of y. The order here doesn't matter because it's addition. Okay? Now, R in, start on the thing you're rotating it about to the closer function. Again, the distance from the y-axis to this is y over 2. But I am adding, I'm making it longer. So I'm adding additional 4. So I get y over 2 plus 4. Does that make sense to everybody? Okay, last one, our final one. We have rotating it about x equals 5. With your partner, go ahead and draw this. Make the bones of your equation. Set everything up and see if you can do this one. Go. Okay, let's go through it. So, for this, you're always going to put your marker, pen, pencil on the thing you're rotating it about. The thing I'm rotating it about is x equals 5. You're going to draw to the furthest function, not the furthest point, the furthest function. Okay, so my furthest function is the green one. Okay, now the distance from the y-axis to the green function, the distance from the y-axis to the green function is y over 2. The distance from the y-axis to x equals 5 is a distance of 5. Does that make sense to everybody? So this distance from here to here is 5. This distance from here to here is the square root of y. What is my R out? 5 minus the square root of y. Oh, sorry, y over 2, y over 2, y over 2. Thank you. Oh, Toshner. Sorry, mixed up where I put stuff and I was reading it wrong. Okay? For my RN, I'm gonna put my pen, marker, pencil, whatever, on the thing I'm rotating about and draw to the closer function, not the closer point, the closer function. Okay, the distance from the y-axis to that function is the blue, which is square root of y. The total distance from x equals 5 to the y-axis is 5. So what goes in for my RN? There we go. Okay. Confidence level on this now. Do we feel better than we felt when we started a half hour ago? 4s and 5s. What questions do you have so far? What questions do you have? Yes?
Quick clarification, so we should first be graphing it to find which one's up top or which one's farthest.
So top and bottom, left and right, kind of out the window for these.
Farthest.
Farthest is what we're always going to say. Because we've done, like, R out could be any of them. R out can be the one on top, R out can be the one on the bottom, R out can be the one on the right, R out can be the one on the left. R out is farthest. Okay? Yes, you should always be graphing it. Yes, you should always be drawing from wherever you're rotating it to the farthest, wherever you're rotating it to the closest. Always. It's not worth any points to do that, and sometimes they will give you, often they will give you a graph in the FRQ. So you're just drawing on their picture. If they don't give you a graph, absolutely draw it. Other questions? Yes?
Why is pi not integrated?
Because pi is a constant, so we can pull pi out in front. It would actually be totally fine if you left it as volume equals, like our original equation. If you wrote it as volume equals integral of pi r out squared minus pi rn squared, like that's our area equation or whatever, right? That's fine, but because they have a pi in both, we can factor out the pi, and because pi is a constant, we can throw a constant out in front. Very good question, okay? What's nice about volumes of revolution is the area equation is always the same, okay? Now, one thing that sometimes will happen is that you won't have a donut, you'll just have a circle. And a lot of books will teach you that this is a totally different method. It's not. Let's say this was like square root of x, for example. And I was rotating it about the x-axis, and it was bounded by the x-axis. Let's say it was like this, for example. Works exactly the same way, and I'll show you how. So let's say we are taking the area bounded by square root of x and the x-axis from 0 to 4, and we were rotating that area about the x-axis, for example, okay, about the x-axis. Still, I'm going to set up volume equals pi integral something squared minus something squared. If I'm rotating about the x-axis, that's this way, so that would be a dx, okay, and I told you that this was 0 and 4. Now, works the same way. Put my marker, pen, pencil on the thing I'm rotating about. If I'm rotating about the x-axis, I put it here. Farthest away function is this one. What would my r out be? Square root of x. Everybody okay with that? Now, my r in, I put my pen, pencil, marker, whatever on the thing I'm rotating about, draw it to the closest function. What's my r in? 0, which can happen, but you don't need a new setup, you don't need a new equation. This is totally acceptable, you'll get full credit for this.
You have to show the 0.
You don't have to, because there are so many different variations. I always encourage you to set this up first. If you get a 0, it just simplifies it. Everything simplifies quite a lot in this one, right? They would probably actually ask you to solve this one. But it's very helpful to start this way, even if your RN is 0. Okay? Any questions?